This is our second unit, probability involving counting principles, permutations, and combinations. I'm going to be looking at the slot method. I'm trying to talk as fast as I can because I only have about 6 minutes, as I found out through YouTube, or else if the video gets too long, it won't stay on YouTube. So please email me if you have any questions, but here is the content for the slot method. So we have an Edward Snowden video, very good movie, I haven't seen it before, and we're looking at counting principles, permutations, and combinations. So permutations, as you'll learn later on, this is when order matters, versus combinations, it doesn't matter the order as long as you get that combination. So right here, we're talking about the slot method. We have a lock here, and we have 1, 2, 3, 4, 5 different slots. And we have the whole alphabets of 26 letters to choose from for the first slot, similarly for the second, and so forth. So if we choose the letter P in the first slot, we can still choose the letter P over here, and then maybe a different letter over here. So we have 26 times 26 times 26 times 26 times 26, which you can see down here for the tree diagram. And when we figure out the solution for it, we can see that how many ways are there to have a password with no restrictions? Well, it would be 26 times 20, just like I said. How many ways are there to have a password if you could only use each letter once? So in this case, we start off with 26 letters, but let's say we use the letter P, but we can't use the letter P here. So now we only have 25 options, and then 24 and so forth. Okay, what is the probability of the password to be written without the vowels? Well, we had 26 letters minus the vowels, so there's now only 21, which is 5 vowels, and therefore we get this solution. Question 4, how many ways can the password be used? Oh, for the word match. So technically there's 1, 2, 3, 4, 5 letters, and it doesn't have to be in that order, so 5 times 4 times 3 times 2 times 1. And the last one is, what is the probability that the password starts with M and ends with H? So the very first letter has to be an M, so we only have one option. It has to be M, so that's why it's 1 there. Similarly, H, there's only one option, so we can put 1 at the very back here. And then in the middle, we have ATCH. So we have 3 times 2 times 1 because we have 3 options, A, T, or C here to choose from. Then we only have 2 letters, and finally we only have 1 letter. And there's 6 possible solutions where you can rearrange the letters match with having M at the beginning and H at the end. It says go to your portfolio. Again, this is a great way for you to have it as a backup if you do poorly on the quizzes. Not required, but beneficial for your learning. The indirect method, that's the complement. You can take a look at the solution here. The one I really want to focus on are the 2 questions you have to do for your Dropbox. So it says play the 4 dice roller in the games fair, so you can play it. It says explain how a tree diagram could be used to explain how many possible ways NS there are for you to roll 4 dice. Okay, so using the slot method in multiple cases, calculate the probability that you would roll 3 sixes. Okay, so for what you need to do is, this is very similar to the factor question up here. And the factor question is right here. It says if you rearrange the letters to the word factor, what is the probability that the vowels are together? So here we go. So the vowels must be together. So the vowels in factor we know are A and O. So let's try the solution here. Okay, so this is the total number of ways to arrange the letters. So we don't care about the vowels being together, and this is the total number of ways. So that means there's technically 1, 2, 3, 4, 5, 6 letters, and that's why we have something that looks like that. And now we have a bunch of cases here. So vowels in the first 2 spots, because we want the vowels to be together. So let's say the vowels are together at the first 2. Well, we have 2 vowels, so it'd be 2 times 1 here. And then we're left off with 4 letters, consonants technically, and that's case number 1. So let's say we move, now we shift the vowels to the next 2 spots. Well, it's similar because we still have A or O to choose from. And then similarly, we continue like that. The next 2 spots, you get the idea, the second and the last 2 spots. And we have 5 cases in total. So in all the cases, when you multiply them, they add up to 48. So there's technically 1, 2, 3, 4, 5 cases. So if you 48 times 5, 240. So up here, there's 720 ways to rearrange the letters when there's no restrictions. But when we restrict it to having the vowels in the 2 spots, we only have 240 ways, cases in total. So technically the probability that the vowels be together is 33%. Okay, so this is very similar to your, this one up here is very similar to the original slot question about the dice, or sorry, the lock at the very top, way up here, where you do your tree diagram. And the second question, 5 students and 2 teachers attend a conference at Statistics Canada. They pose for a picture. And how many ways can they line up side by side for a picture? This is when you have technically 7 people in total, so it might be 7 factorial, but you need to show the math like it shows up there. And then the second question, how many ways can they line up if they must have the teachers on both sides of the picture? Keyword is both sides, so when you do your work up here, it's going to be very similar to the factor question that we just did, and you have teachers on either side, so it would be 2 at the very beginning because you have 2 teachers to choose from, and 1 at the very end, and then you might have 3 times 2 times 1 for the students in the middle. And the last question is the most difficult question that I'm not going to really help you out with because I want to see if you truly understand it. It says, what is the probability that 2 teachers occupy 2 of the 3 middle slots? But again, it's very similar to the factor question that we just discussed. And email me if you have any questions. Thank you.